Hello, this and my other YouTube videos are extracted from the History of Man series, currently 6 books published in print, ebook, and most importantly, audiobook. I'm a storyteller, and if you like these video stories, you'll love the History of Man series audiobooks. Great for commuting or just sitting back and relaxing. And unlike a novel you've read where you know the ending, you can listen to these books on tape more than once. There's so much to learn. Available on Amazon and audible.com, I narrate the audiobooks. And the best part about that is you can listen to these stories without having to look at my stupid face. And with that said, let's get the show on the road. Hello, this is John Bershoff with another episode of History of Man series. This one is Global Warming 101, Part 2. There's 4 parts. You should watch them in order because they build on each other. In Global Warming 101, Part 1, we discuss the 3 periodicities of Earth. The 100,000-year solar oblong eccentricity around the sun, the 41,000-year axis tilt obliquity change, and the 26,000-year wobble of Earth called precession. And when these aligned in a certain way, they triggered an ice age. Now, during the last ice age, the Pleistocene epoch, it began about 2.6 million years ago, and it petered out about 20,000 years ago. The temperature during that ice age averaged about 47 degrees Fahrenheit. As Neanderthals and Cro-Magnon were fighting it out on the human stage in Europe, for the last man standing, last woman too, temperatures began to warm around 20,000 years ago. When the Neolithic age dawned on humanity with the domestication of animals, dog 15,000 years ago, sheep and goats 10,000 years ago, Earth had warmed to a comfy 57 degrees Fahrenheit. That means it took 10,000 years for Earth to warm 10 degrees Fahrenheit, or 1 degree for every 1,000 years. Remember that, 1 degree for every 1,000 years, Earth warmed. That is normal global warming, slow, plodding. The sun's radiant heat warming our planet. That is normal global warming. Earth is buffered under normal conditions by any rapid change in climate. Life would not take hold if climate was chaotic. Life depends on stability. Yes, it can change a little bit, but slowly over time for life to adapt. Earth global temperature has hovered for 10,000 years around that benchmark, 57 degrees Fahrenheit. You might say it's our sweet spot. Yes, there's a picket fence to Earth's annual global temperature, but it always hovers around 57 degrees Fahrenheit. Now, you don't conflate weather with climate. You need to see my video on weather and climate. Weather is chaotic. It's what's happening outside your window, and outside my window, it's snowing. Climate is stable. It's loath to change. Climate is a 30-year average of weather data. And that is the main difference between weather and climate. Remember that. Now, consider this. Global temperatures have been rising about 1.5 degrees Fahrenheit over the past 50 years, and 2 degrees Fahrenheit since 1880, when global temperatures were started to be taking place with thermometers. That is not normal. Normal is 1 degrees, as we said, over 1,000 years, not 1.55 degrees over 50 years or 2 degrees over 150 years. That rate of global warming is 40 times faster than normal. Dare I say, it's abnormal global warming. Other than a huge asteroid strike, like the Chicxulub asteroid strike 66 million years ago off the Yucatan Peninsula of Mexico, hurling dust into the air that blighted the sun for several thousand years, quickly changing the climate. The climate is loath to change. Under normal conditions, the change is slow. Circumstances are slow. It can get pretty cold during an ice age, ice house Earth, and pretty warm during hot house Earth, some of which were actually extinction events, like the Cambrian explosion 530 million years ago, when things were getting warm and ripe for the explosion of life. But then the subsequent Permian extinction 250 million years ago, when things got so hot that 90% of marine species and 70% of terrestrial species entered the fossil record. Fortunately, no phylums down to order were lost. You know, that kingdom, phylum, class, or family, genus, species rhyme. But as for family, genus, species, the Permian extinction, many family, genus, species entered into the fossil record. To emphasize, Earth has warmed 2 degrees Fahrenheit in just over 150 years, 1.5 in 50 years. That's not normal, never has happened. Now, how do we know ancient temperature timelines? Not exactly T-Rex and pals had thermometers and recorded those temperatures for us, nor did Neanderthal or Cro-Magnon have thermometers. It is believed that Italian scientist Santorio, no, that's not a mistake, it's not an echo, first and last name are the same, I guess, in 1612 is credited with inventing perhaps the first thermometer. It was very inaccurate. He used air expansion, I believe, to get a bead on the ambient temperature. Air is a gas, and as it heats, it does expand, but it's not very reliable. In 1654, the Grand Duke of Tuscany, Ferdinand II, isn't there a children's book named Ferdinand? But anyway, he used alcohol expansion as a gauge to measure temperature, just a scale, since alcohol expands slightly with heat. Still not very accurate. It was in 1714 that, you might have guessed it, Gabriel Fahrenheit used mercury inside a glass tube to create a very accurate temperature scale and a way of measuring the temperature, since liquid mercury is exquisitely sensitive to slight variations in temperature. More heat, more expansion. Confine mercury to a tube, and there's nowhere else for the mercury to go but up that tube. And for that matters for us because digital temperature probes were invented, fortunately. But when I was a kid, they were mercury in glass tubes, and they went not only up, they went up the butt when mother took our rectal temperatures. I'm glad those glass thermometers back then did not break. Can you say mercury poisoning? But anyway, Celsius scale was invented in 1742 by the Swede Anders Celsius. The Kelvin scale was invented in 1848 by Sir William Thomas, Lord Kelvin of Scotland. And his scale was absolute zero temperature. So what does all this mean? First of all, why did Fahrenheit choose 32 as the freezing point of water? He didn't. What he did was, the coldest he could get a mixture of ice, water, and salt was, with his thermometer plunged in, was the concoction that he assigned the value of zero. So he put his thermometer in of ice, water, salt, the coldest he could get anything, and that was his zero. It just so happens that when pure water on his scale froze, it was at 32 degrees Fahrenheit. Now, Celsius probably correctly decided that where pure water froze, not salt water, but pure water froze, should be the standard, the zero, especially since water is essential for life throughout the universe. So on his scale, the freezing point of pure water is assigned zero. As for Kelvin, well, he had other things in mind. He wanted a temperature that is believed to be the absolute lowest temperature in the universe, where there is literally no thermal energy, none, zilch. He assigned that 0. A Kelvin 0 is a Celsius minus 273.5 and a Fahrenheit minus 459.67. As an aside, Fahrenheit 451 is a 1953 dystopian novel by Ray Bradbury where books are outlawed. Sounds like some states right now in America. And they were burned. There was censorship, thought control, similar stuff to other dystopian novels at the time. George Orwell's Animal Farm, 1945, or Orwell's 1984, published in 1949, and Aldous Huxley's Brave New World, published in 1932. But as for Bradbury using 451 degrees Fahrenheit as the title, it is the temperature where paper in books spontaneously ignites without the need for a flame. It is believed that attending absolute 0 Kelvin anywhere in the universe is impossible, although it has been approached. Now, I won't bore you with the great details, but the closest humans on Earth have come to absolute 0 was in 2021 on the International Space Station, and they were doing it to study what are called Bose-Einstein condensates. They got the temperature down to like 0.00000, a bunch of zeros, 38 Kelvin was reached, not 0 Kelvin, but close to it. And they did this using what was called microgravity in a cold atom laboratory that happened to be on the International Space Station. And I won't go into details on that because I don't understand it. Now, what is a Bose-Einstein condensate anyway? Why were they trying to get down to absolute 0? You wish you hadn't asked, right? A Bose-Einstein condensate is the smallest subatomic particle, maybe like a single photon or even smaller, of light that has no movement, no spin. If you could get a subatomic particle cold enough, you can study the wave function. The wave function, what is that? You wish you hadn't asked, right? Well, in quantum mechanics, you supposedly can know the velocity of a subatomic particle, that's a wave function, or the location, that's a wave function, but you cannot know both simultaneously because measuring one alters the other. It's called the Heisenberg uncertainty principle. You can't know both where a subatomic particle is or its speed at the same time. That's why this experiment to get down to absolute 0 to study Bose-Einstein condensates, because at absolute 0, you can maybe know both at the same time. Schrodinger's cat is popular in TVs and the sitcom The Big Bang Theory, and it shares a concept with the Heisenberg uncertainty principle, but it also does not. At the time Schrodinger created his thought experiment, some physicists were claiming a certain observation in quantum mechanics, viewing a quantum state that would then collapse to a single state, was not really collapsing. It was only collapsing because it was being observed by a scientist. Schrodinger believed that quantum states could collapse. So he invented this thought experiment with a cat in a box, and you can think of the cat as alive or dead. There's a poison in the box that either is released or does not release. And so when you look at the box, you cannot know whether the cat is alive or dead. That is Schrodinger's cat experiment. Of course, it's irrelevant if it is viewed by us puny humans. It's sort of like a tree falling in the woods, makes no sound if no one hears it. Well, of course it makes a sound. So quantum states exist. We don't have to necessarily view them, which is what Schrodinger was saying, but they're there. Anyway, that's the end. In Global Warming 101 Part 3, we'll discuss how scientists construct ancient temperature timelines going back to even before dinosaurs, to even before the first bacteria, all the way back to Keith Richards' birth, because there weren't thermometers before 1880 used to measure global temperature. They existed, but they weren't put around the earth. Anyway, that's the end of part 2. This is a History of Man series. This is the first History of Man. I have 6 books out, more to come. It's a style of writing called jumping off, where I have a base subject, which is medicine and science, but I jump off into other subjects, physics, as you just experienced, into astronomy, into geology, into art, into music, into philosophy. I always come back to the subject and then jump off, come back and jump off. It's not a style of writing for everybody. Some people might find it difficult to follow, but I promise you, you'll follow it. And with the turn of every page, you'll probably learn something. Thank you very much. These books are in print, in Kindle, ebook, and in audiobook where I do the narrating. Anyway, thank you very much for listening. Go to part 3 and part 4 of global warming. Thank you very much. Have a good day. Be well.